So in our previous class, we were able to carry out our grid lines and insert our columns and even create our shear walls for our lift. Today we are also going to, in this video, we are going to insert our slabs and our beam. So I'm going to do that. I'm going to be brief. So after you have done your general arrangement, the next thing you do is your modeling. So for our previous video, for those of you that are just watching this video, you can search our video, our previous video, and check how we're able to carry our general arrangement in our Protastructure. So today we are going to learn how to insert our beam. So I'm going to use beam. We already know that the size of our walls are 225. Oh, okay. So there's a mistake here. I said 225 by this. So this is what I'm going to do. Okay, let me just click on one column and I'll select this. I'll come here, shift, select the last one. So what I'm going to do is I'll just click on properties. So I'll click here, I'll scroll down, so I have 450. So I can select everything. Let me come to properties. So I'm going to use 225. I just type 225. Now auto edit everything. It's done. So the next thing I do is just close. Everything is now 225. So I'll come to this one. Let's change this to 450. Sorry. Let me just install this one back. So sometimes you can just auto edit this if there's any mix up on the way. Let's type 450. So I can use this. Instead of coming this side to edit, I can just insert this, then I delete this. For this 450. This goes 450. So every other thing is 225. So let me go to modeling. I go to my beam. So thickness of my beam will be 225. The depth of my beam for now will be 450. I can start this way. And then I can take it all over to this place. And I can say take it to this place. So let me take it to this place too. Come to this side. From here, I'm going to keep it here. I'll delete that. This is what I have here. So this will come here, and this will go this way. So now let it stop at this place. have this spanning this way, and this to here, out to this place, and then I'll reduce the span here. So I have another one for my staircase here. So I have this to here, this to here, and then I reduce the span over here. This to here, and then this to this point. So this building, that typical at both sides, so I will ensure that what I've done to this side I also do to this side. So I will not want to change the arrangement of my beam the way I've done in the left side. Everything still remain this way. And this will come all this way, and I break it here. I break this here too. So I'm done with this. So the next thing is to insert this cantilever slab all the way to this point, and from here to this point. So this is what I'm going to do. It's either I will use my polyline or I will use my cantilever slab. So we are done with inserting of our, okay, I need a beam at this point. Need a beam at this point. Let me even break this here. So this is it. So like I said, we will either be using our polyline or our cantilever slab. So first instance, we'll be using our cantilever slab. So I will just measure this where our this is starting. So the cantilever is going to span out 1.2. So like our first design here, I'll be teaching how to use your cantilever slab. So we just change to 9, and we'll change to 12. This is a cantilever slab. See the cantilever here. So the thickness of a cantilever, we want to use 175. Then the load is going to be a balcony. Then I will enter cantilever length as 1,200, and then my load is 9.3. So I'm going to start from here to here. You see it here, from here to here. So I'm going to span this one to here. And this to here. And then the porch. So I'm going to do this and we'll check our 3D, and then we know what to do. So I have my porch here, so that means I'll insert it here too. So we are done with our cantilever slab. So let us check our 3D. So it's actually stopped from here, but you have a slab here, and then this one projecting up to this. I'll be teaching you how to do that too. I have a slab at different levels. So the next thing is we we're going to do, I would like to insert our slabs in these partitions. So I'll go to slab. This time around I'm not going to use that. I'm going to use one that is supported all around with your beam, and the thickness of my slab will be 150, and the load where is room, the imposed load is going to be 1.5. I'm trying to insert my slab. So even for your staircase, you can insert your slab so that you determine how the beams are going to be loaded with your load. Let me insert. Since there's an opening here, so I will join this up. So I want this to be my primary beam, so that's why I'm not breaking it. So I can use another way to insert my slab at that point. Pick point, pick that point, pick point, pick, and I pick this. So I can also do the same thing and insert my slab at this point. So let me see the distance. So I can click here, I'll pick my point. So I'm done. So after we have inserted our beam and our slab, the next thing we do is going to load our beam. I will just click on one of the beam, and then I go to edit wall load. So under edit wall load, I'm going to insert your wall unit weight is going to be the weight of your Nigeria blocks, and then we have standards for that, which is 3.47. That's the standard for Nigeria blocks. And the height, so the height of your building is always the height given to you by the architect minus the thickness of your beam inclusive of the slab. So I have 3,600 minus 450, then I have 3.150. Well, this is in millimeters, so this is in meters, so it's going to be 3.15. Then the wall thickness, everything is going to be in meters. This is 0.225. And I click OK. So I'll now copy this. I'll select everything. So let me paste it at this side. Okay, yes. I will do the same thing to my left, but I will not select my lift walls or my shear walls. I can just say Ctrl V or right click and click on paste. Okay. So I'll select this. And I select this too, and I click on Ctrl V or right click, whichever way I want to do it. Then I say paste. So this is how to insert your slabs, your cantilever slab and your normal slab, your two-way slab, your one-way slab, and then how to load your beam, apply your wall load on your beam. So I'm going to insert the number of stories now. So if I'm working with a 3 suspended floor, then I'm going to insert 4. So it means that if I have 1 suspended floor, it's going to be 2. If it's going to be 2, then 3, 3, 4. So this is 4. Okay. So I'll go back to 1, story 1. I'll click on story again, then click edit story. So I'm going to edit this. This is 3,600, 3,600, 3,600, 3,600. Then I'll zoom roof as normal story. Then the foundation depth. Although foundation depths are usually specified by the test from the from your soil test reports. If the soil test was actually carried out at a depth of 1.5, then your foundation depth is going to be 1.5. It is carried out at 2 meters. It's going to be 2 meters, and the type of foundation you are going to design actually depends on the nature of the soil, and the values are actually gotten, or the structural engineer will have access to the value from the soil report. So this is going to be, for now, we are going to work on our zoom soil test report, which is, let's assume it was specified as 1.5. So everything is in millimeters, so I will say 1,500. Okay. So let me create an opening for my lift wall or my shear walls. So I will click on it, then I will go to wall opening editor. Under wall opening editor, I want to click on add. I've done this in one of my tutorial videos. You can search my YouTube for the video. I just click 0 at that side, then the wall height 2,100, then I say okay. So my lift or my shear wall now has an opening. It's very important you create this, because you are going to carry out the analysis, and the analysis, if you don't create that, the software will assume that it's a solid shape, and then the reinforcement may not be adequate when you want to implement or execute a project. But for the design, because it's what you garbage in, the system will garbage out. So please, you have to follow all of this. You can check one of our tutorial videos on lift design, and you have a good knowledge on how to design your shear walls. So I will just go to my analysis. Let me edit my material. So on the foundation, the bearing capacity is at zone as 1.2 kilonewton per meter square. You can leave this as lower limit or upper limit, depending on what you want. Then I edit, select all. So for my columns, I'm going to choose Y16, Y20, and Y25 for my columns. And then for my concrete walls, I'm going to choose Y10 and Y12. Then for my concrete beam, I'm going to select all. I choose Y16, 20, and then 25. And then my slab design is going to be, it's always 12, only for special cases that you use diameters are above 12. So my links is 10. Then I'll go to foundation. Under my foundation, I'm going to choose Y16 and 20. Now Y16 and then Y20. Links will remain constant. So I'm done with this. Okay. Then I close. So I can still do some settings. So under my beam, I'll first go to my beam design. So I can go to detailing, then section. I choose this. Print number of links under my sections. Span section support olive. I want to have sections where there are varying or different depths of my bin. Then I'm done with my bin. The next thing I do, I'll go to slab, under slab, I'll go to my rebars. So my maximum spacing should be 200. Then appearance. Okay, I'm done with that. I'm done for bin and slab. I'll go to my foundation. So if I'm going to design for my pad, the higher depth of my pad should be 300. Then I just want it to be reinforced at the bottom only. Then my spacing for my reinforcement is going to be 200. So I'm okay with that now. So this is where we're going to stop in this video today. And do subscribe, like our YouTube videos and channel for more of our tutorial video. I remain Benedict from GM-BIST Construction. Thank you.